Welcome back to my derivatives example series where I basically make 3 examples, run through them, show you how to do them. This is the 8th episode. Each episode from the first has gotten progressively harder, and I try to add different techniques in. So if you're not comfortable with derivatives, I'd suggest watching them because there are techniques that I show you that aren't commonly used but are at the same time. Anyway, let's get right to it. These are the 3 examples, and I'll go through them one by one. We'll start with example 1. So we have y equals e to the power of x over x take 1. Okay, so what we're going to do is we're going to do the chain rule, and we're going to let u equal x over x take 1, because doing the chain rule with this, it's not as easy just to say derivative of e to the whatever multiplied by the derivative of whatever. We need to take a bit of time to do this. So that will now equal e to the power of u. We can establish the next step is the derivative will be e to the power of u multiplied by the derivative of u. Now, what we need to do is find out what the derivative of u is. We can use the quotient rule here because we've got a function over another function. We'll say the top one is a and the bottom half is b. Okay? That means u will equal a over b. U dash will equal a dash b minus a b dash all over b squared. Derivative of a. If a is x, the derivative is 1. Multiplied by b. b is x minus 1. Minus a is x. Derivative of b is 1. b squared. X minus 1 squared. This can be written as x minus 1 minus x over x minus 1 squared. And if we simplify that further, we get rid of the x's because x take x. And then we just got negative 1 over x take 1 squared. And that's our derivative of u. So we're going to sub this in. E to the power of u. U is x over x take 1 multiplied by u dash, which is negative 1 over x minus 1 squared, which will look like negative e to the power of x over x minus 1 over x minus 1 squared. And this is the derivative of the top function, if you can see it. Now, I'll do the second example. Y equals e to the power of x minus e to the power of negative x over e to the power of x plus e to the power of negative x. Now we're going to need the quotient rule to solve this. So we'll label the top u and the bottom v. Okay. Means the derivative would be u dash v minus u v dash over v squared. U dash. What's the derivative of the top half? Well, derivative of e to the x is e to the x. Derivative of negative e to the x, e to the negative x is plus e to the negative x. Why? Because this bit stays the same when derived, but you would derive the top and then multiply that. And the top, the derivative of the power would be -1. If you multiply -1 then you get +1. So you would end up with this. Okay, now uv, which is e to the power of x plus e to the power of -x, minus u, which is e to the power of x minus e to the power of -x, and then derivative of v. First, e to the x, derivative is just e to the x. Derivative of positive e to the -x becomes negative e to the -x, because when you derive this, everything stays the same, but the -1 from the power comes down. And it's all over v squared, which is e to the x plus e to the -x squared. Now let's simplify it. This times this is the exact same as this, so it becomes e to the x plus e to the -x squared minus these two, the exact same, so it's e to the x minus e to the -x squared, all over e to the x plus e to the -x squared. As you can see, this is the same as that, but this is not the same as that. Therefore, we're going to have to split it. What's splitting going to do? Well, we're going to have e to the x plus e to the -x squared over e to the x plus e to the -x squared minus e to the x minus e to the -x squared over e to the x plus e to the -x squared. This equals 1 because it's the same thing over the same thing. They're the same as each other. So that becomes 1 minus e to the x minus e to the -x squared over e to the x plus e to the -x squared. And there is your answer, your derivative. Okay, now for the third example. We have y equals x ln x minus x. We're going to label this as u and this as v and use the product rule to solve. So the derivative is going to be u dash v plus u v dash, and then we're going to add on the end. The derivative of minus x is minus 1. Okay. Derivative of u. If x is u, then derivative is 1. So 1 multiplied by v ln of x plus u x. V dash is derivative of ln of x, which is 1 over x minus 1. If we have ln of x plus x over x is 1 minus 1, cancel out, ln of x. Which makes sense because if we were to find the integral of ln of x, we would get that. So by deriving that, makes sense. Okay, thanks for watching. I hope you learnt something, and have a good day.